Comparisons. I've looked at equals and some range comparisons in the previous movie. All I'm going to do is tell you the rules. An equals or equality, searching for a single row is always the fastest, without a doubt. Ranges are slightly less efficient than equals in that they actually execute index range scans. Obviously, an equality check against an index which has duplicate values will actually execute an index range scan. Equals can potentially execute a unique index scan, which is the fastest form of access into tables. Range scans are, as you can see, all these operators plus the between operator. Try to avoid using not equals, not, and like because they read the whole thing. They can potentially read an entire table or an entire index, but most likely an entire table. Why? Because if you're going to find something which is not in something, it's a negative. You have to read the whole table to make sure that it's not there. You can't go and read a single row because it doesn't exist. That applies to not equals and not. Like as a pattern match, there's no index and there's no way to create an index for a pattern match in Oracle. However, in Oracle 10G there is quite extensive use of expressions and pattern matching, and there are some ways in which you can actually tune this type of pattern matching processing into tables, but that's well out of scope for this course. The fact is, not equals, not, and like will read the whole table. Try to avoid using them unless you absolutely have to, because if you need to find a single row in lots of rows, you're going to read the whole table anyway, and that's slow. Traditionally, in is slower than exists. Exists is faster than in. I would say that this is not necessarily the case anymore in the latest release of Oracle 10G. Generally, exists is used for subqueries, and in is used to check against literal sets. Additionally, exists can create a correlation between a calling query and a subquery. What it means is that a calling query executes a row, passes a value into the subquery, and the subquery can find a single row or a set of rows based on the value passed in. Without the correlation, the subquery simply executes every row for the table underneath for each row in the table it's calling. So effectively what you're doing is you're actually executing a Cartesian product like that. With a correlation, you're not actually executing a Cartesian product, you're executing what is effectively a join. It's called a semi-join. We'll get to that detail later on. However, I have found experimenting with 10G that in is actually sometimes faster than exists, and in can actually do correlations between calling and subqueries as well. So this particular set of facts is in doubt. However, in 9i, exists is generally accepted as being faster than in applies to literal set checks, and exists applies to subqueries. That's the real basics of comparisons. I'm not going to show you any examples for this movie because these are simple facts.